Good day, dear students. Hope you are well and catching up with our lessons. Last week, you have studied Chapter 4, all about the elements of traffic analysis. This week, you will focus your study on Chapter 5, on vehicle performance and characteristics. This chapter will give you an introduction to the basic elements of road vehicle performance. It is important for you as civil engineering students to understand the principles involved in vehicle technologies and its effects on the development of road guidelines. So the learning objectives of this chapter is for you to be able to discuss the importance of vehicle characteristics to the transportation system. Second, identify the vehicle type and sizes. Third, calculate the tractive effort resistance, determine the maximum vehicle tractive effort, and then calculate the braking proportions that are to be allocated to both the rear and front wheel of vehicles. With these objectives, we will cover the following in this chapter: the introduction to the chapter, the vehicle type and size, the vehicle tractive effort and resistance, the maximum tractive effort, and the principles of braking. Now, the road design is governed by two main factors. We have the vehicle capabilities and the human or the driver capabilities. For the vehicle capabilities, the vehicle can either accelerate or move to a higher speed or decelerate. This is to reduce the speed of operation, or it can also brake to a stop. Now, for the driver, you might have known or heard about the two types of driving in the Philippines, the defensive and the offensive driving. But anyway, whatever kind of driver is that we have here in the Philippines, the two main elements that are crucial for the design of roadway and the guidelines is the perception reaction times. This is related to, for example, what will the driver do if he sees something or an object ahead? Will he decide to stop or just decelerate or move to the other lane? So those decision-making time entails the perception and reaction time of the driver. And the second important element of the driver is the eyesight, because it allows him to see whatever is ahead, for example, the signs, or if there is an obstruction ahead, then the driver can decide to stop, and so on. Now, the performance of vehicles serves as the basis for roadway design guideline development. And for example, how much length of acceleration are you going to designate on the lane? Or how many meters of deceleration lane are you going to put? And for another example is the maximum grade, the standards for stopping sight distances, depending on whether that's a sag curve or a level highway or a sag curve, and the speed of operation as well. And also the passing sight distance. So how many percent of the road length are you going to designate for such? Or setting speed limits, what will be your basis for setting the speed limits? Do you put it at 60 kilometers per hour or higher? And the performance of vehicle also sets or helps in the designation of the timing in signalized intersections. Now, why are we studying, or why do we need to understand the performance of vehicles? Because we have two important purposes for this. The first one is it provides insights into the roadway design and traffic operations and the compromises that you may include in the design standards. And second, it forms a basis on which to assess the impact of advancing vehicle technologies on design guidelines. If you have noticed, vehicles have improvements every time. For example, the Toyota Vios, it has a new version or edition every year. New edition means a new improved feature. It can be the safety feature or the speed or the ability to go up and down a grade and so on. So with the vehicle technologies that are improving, the design guidelines are also needed to be updated accordingly. So we were talking about the vehicle type and size. Let's look at the vehicle types and sizes that we have. And before going to that, let's take note that vehicles influence the following. First is the clearance for bridges, tunnels, and grade separation. Looking at this figure here, you can see this is the skyway. It's a picture of a skyway from Alabang leading to Manila, Metro Manila. You can see one level here and there's another level of link here. And this link leads vehicles to the NAIA terminals. Okay, so if vehicles are allowed to ply on this link, this next level should be designed at a height that will allow vehicles to pass here safely. You can see that the passenger cars here can pass through safely, right? There's enough clearance. But how about trucks? So if trucks are going to pass here or allowed to pass here safely, then it should have enough clearance. Now in our design standards, there are already set minimum clearance heights that are required if you're going to put a next level of highway link here. And another one is vehicles influences the geometric design of streets, roads, and parkings. This figure here, as you can see, is a T intersection in a village in Laguna. So you can see there's a maximum speed of 20 kilometers per hour. What's the basis here? So if this is a T intersection, the turning radius here and the width of the lanes are supposed to be sufficient enough for the vehicle type that is allowed to turn left or turn right in this road. And design also requires information on the maximum and minimum dimensions, allowable weights, and minimum width of lane, and so on. So now let's look at the vehicle types and sizes that we have in the Philippines. As you can see in these figures or pictures, these are big bikes. So one category is the motorcycle. These are motorized 2 or 3-wheeled vehicles that can transport 1 to 2 people. And since these are as the size that you can see, it can operate in any of the street or highway that is designed for cars and trucks. And these type are given little attention and consideration in highway design. The next vehicle type is the passenger cars and the light trucks. This is an example of a passenger car, and this is an example of a light truck. Usually, these dominate the traffic in highways. They typically weigh about 680 to 1,800 kilograms and can accommodate 2 to 6 passengers. The next type is the single unit trucks. These have cargo and power unit. This is the power unit, and this is an example of the cargo, and it's usually mounted on a frame. And these type of vehicles, they can range from 2-axle, 3-axle, or 4 axles with the given weights here. And these are commonly used for hauling freight that are related to short distances only. Now, the next vehicle type is the combination of trucks. These are bigger than the one in the previous slide. So this has a power unit and a tractor. And it has a connection here that allows them to be separated when not in use. And we also have a van. These pictures here are examples of a van. This picture here is a van in Thailand. And these are passenger vehicles mounted on an automobile or light truck that is capable to have 6 to 15 people. We also have buses, which has a capacity from 15 to 75 passengers. And we have recreational vehicles, which are various configurations, including the passenger cars with trailers, pickup trucks with camper bodies, and motorhomes. Usually, these vehicles perform poorly because they are more heavily loaded than the other types of similar size vehicles. So those are the types of vehicles, and now let's move on to the vehicle tractive effort and resistance.